Hello everyone, welcome. In this video, we are going to solve a problem from stem and leaf plot. So let's first read through the problem and then start solving it. A student in a statistics class took their first test. Following are the scores they earned. Fill in the stem and leaf plot below and use the tens place as the stem and ones place as the leaf. Describe the shape of the distribution. So the data is given here and we have to complete or we have to construct a stem and leaf plot. And in the stem and leaf plot, normally what we do is in a stem and leaf plot, we consider the rightmost digit as a stem and remaining digit as the leaf. Here we have two digits number only. So in this case, the tens place digit will be the stem and the ones place will be the leaf. So in a stem and leaf plot, normally what we do is, to construct the stem and leaf plot, we begin by drawing a vertical line to separate the stem and leaf like that. And then we look at these numbers. So if we look at these numbers, we have 92, 93, 72, 71. So in this way, if we scan through all these numbers, we can see that there are numbers in 50s. So let me write 5 for 50s. There are numbers in 60s. There are numbers in 70s. There are numbers in 80s, and there are numbers in 90s. So what we'll do is we'll look for this one, we'll first look at all the numbers in 50s. So here, if we look through the numbers in 50s, here is 1, 59. If we look for the numbers in 50s, here is the other one, 53. So those are the two numbers in 50s. So we have a 53 and 59. So we write it as 5 and 3. That is 53. 5 is here and then 9, 59. So that's how we can separate the number and write it as stem and leaf. So that is for the numbers in 50s. Now let's find the numbers in 60s. Here is 1. And then the next number that we have is this one, 62. So we have a 60 and 62. 60 we write 60, 62 we write 62. So that is for the numbers in 60s. Now we're going to look at numbers in 70s. So for numbers in 70s, here is 71, here is 72. Similarly, here we have a 77. Here is a 71. Here is a 71. I think that's all we have. So we have 71, 3 of them. 371. So 1. Is it 3? Yes. 1, 2, 371. Then a 72. 72. And then we have a 77. And then we have a 77. So that, oh, here is the other one. There is 74. So we can write like this, 74 and then 77. 74 and then 77. So we have 1, 2, 3, 4, 5, 6 numbers in 70s. 1, 2, you can count here now. 1, 2, 3, 4, 5, 6. 6 of them in 70s. Okay, that's from 70s. Now we are going to look at the numbers in 80s. So let's find them. Okay, first I'm going to erase all this. Okay, now let's find the numbers in 80s. So for the numbers in 80s, here is the first one. This is the second one. This is the third one, fourth, fifth, sixth, seventh. So there are 7 numbers in 80s. And if you look at all these numbers carefully, the smallest one is a 81. So we have 181. And then next we have is a 82. Here is 1, here is 1. So 282, 82, 82. Then we have 285. So 85, 85, 186, and then 189. So those are the numbers in 80s. We created the stem and leaf for those numbers. Similarly, let's look for the numbers in 90s now. So here we have all numbers in 90s. Here is the other number in 90. That is 97, that is 95, 92, 98, 98, 93, and then 95 here. So those are the numbers in 90s. We don't see anything other than that. These are the numbers in 90s. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. So there is no 90, 90. There is no 91. As you can see, we have 92. Here is 192. And then here is the other one. So 292. So we have 292. So 92, 92. Then we look for 93, 193, 293, 393. We have 393, 93, 93, 93. Then we go for 94, if any. There are no 94. So now 95, here is 1. And then here is the other one. So we have 295. Check one more time. Oh, there is a 94. Here is 94. So first 94. And then we have 1, 2, 395. 395. There is no 96. Here is a 97. 197. Then we have 298. There is 97, 98, 98. So we are done with all numbers. So what we have done is we kept the, or we put the unit digit or ones digit in the leaf and the tens digit in the stem, and we created the stem and leaf plot here. So that's how we can create the stem and leaf plot. So that will be the answer for part C. Create the stem and leaf plot for the data. Now let's try to answer A and B. You could have answered A and B first and then move on to C, which is totally fine. The first part is the data collected were for, this is for one variable qualitative data. So we can write it as one qualitative, I mean quantitative, it's not qualitative, it involves number. So quantitative. Quantitative variable. So the data is collected for one because we have a single data, it is just the scores, and it involves numbers, so quantitative variable. So can we make the stem and leaf plot for the given data? That's the question for part B. The answer is yes, because the data is qualitative. Because the data is qualitative. Data is I should say quantitative. I don't know why I'm using qualitative. It's quantitative. It involves numbers, so quantitative or numerical. So for numerical data, it is okay to create a stem and leaf plot, and the data size is also small. So if we have a small data size and it involves number, quantitative or numerical, you can create a stem and leaf plot. Here we have created this stem and leaf plot. And in part D, we are asked to talk about the shape of the stem and leaf plot. When you think of the shape of the stem and leaf plot, normally what you do is we try to analyze this shape. So the way we analyze this is, for example, let me try to show you something. Here we have the numbers like 5, 6, 7, 8, and 9. These are the numbers in front. And then in 50s, we have two data values. So I can do it like this. I have two data values. I can just put the points to represent that. Here we have two of them again. So two of them, just like that. I'm just checking the height for each. In 7, we have 1, 2, 3, 4, 5, 6. So if I draw 1, 2, 3, 4, 5, 6, it might be that much tall. And then in 8, we have 1, 2, 3, 4, 5, 6, 7. So if I draw 1, 2, 3, 4, 5, 6, and then 7. And for the last one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we look at this data set, you can see that the tallest data value is there. And this side, we have a longer tail. This side, we don't have anything. That means it drops down like that. So if you look at the shape of the distribution, you can see that most of the data value is on the left of this tallest height. Meaning of that is the data is skewed to the left. So we say data is left skewed. So quickly you can draw something like this one, something like a dot plot, and then look for the skewness of the data. So this is how we can use the stem and leaf plot to answer the question like this one. That is the end of this video. I hope this is helpful. Thank you for watching.